Today's lesson, we are still looking at the focus standard from grade 8, expressions and equations, number 3. Use numbers expressed in scientific notation to express very large or small quantities, and to express how many times as much one is than another. So our topic today is scientific notation, comparing quantities by estimation. So we're really kind of looking at the second part of the focus standard of how to compare how many times as much one is from the other, or how much bigger it is. We're not quite at scientific notation yet, but we're almost there. So our essential question is, how can we use magnitude to compare quantities by estimation? So take a moment, as always, pausing the video if you need to copy down your header, include today's date, sub your question column and your note column, and resume the video when you're ready to begin. So I wanted to start today with a little bit of review, because if we are comparing quantities by estimation, we have to review what we have learned previously about ratios. So when we want to compare values, which we are doing today, we're comparing quantities, we do so by division. And we use ratios to show that. So ratios compare values by division. And order matters. So when you're given a word problem, the way that you set up your ratio is based on the order that it's listed in the problem. So whatever's listed as first is A in the numerator, and whatever is listed second goes as B in the denominator. So we're going to be setting up ratios using magnitude to compare quantities. So to do so, there's about 4 steps. So here's the first step. We want to determine the magnitude of each value. So going back to our magnitude by powers of 10, we're going to figure out the magnitude for each value that we want to compare. And then we're going to write the ratio to compare the values, and we'll follow the order they're listed in the problems. And then we're going to simplify the ratio using our laws of exponents. So if we're comparing by division, we're going to specifically use the division rule in our laws of exponents to simplify it. And then, of course, with any word problem, we want to state our answer in a complete sentence. That would be step number 4. So we will be utilizing all 4 of these steps today to look at 2 different practice problems of comparing quantities by estimation. Let's go ahead and look at our first problem. So the first census conducted in Portland, Oregon was in 1850, and it listed that we had 821 residents, which is interesting to note that this is the largest settlement in the Pacific Northwest at the time. In 2016, Portland is said to have 583,776 residents. So what we want to find out is about how many times more residents were there in 2016 than in 1850 living here in Portland, Oregon. So I've laid out some room for us to do our 4 steps. So our first step is that we need to determine the magnitude of each value. And I'm going to go ahead, knowing that I have to do it as a ratio, I want to set that up in the order that it's listed. So when I look at the question, it says how many times more residents were there in 2016. So that's first. So that's going to be my A value. And 1850 is listed second, so that's going to be my B value. So we have to find the magnitude of the population in 2016 for A, and the magnitude of the population in 1850 for B. I've left some room for you there. Go ahead and try that out. So remember, magnitude is talking about the number of place values that a number uses. And so since I see 6 place values, we would say that the magnitude for 2016 is 10 to the 6th power. And in 1850, it's listed as 821. I see 3 place values there, so it's going to be 10 to the 3rd. So we figured out the magnitude, and now we're ready to write our ratio. So I've already set it up as A and B, so ratio compares by division. Fractions are a form of division, so I'd write my ratio as 10 to the 6th over 10 to the 3rd. And so now this is looking like problems we were doing a lot of to practice our laws of exponents. So how can we simplify this? We want to go ahead and simplify it using our division rule. So since we are dividing, the shortcut would tell us that we could go ahead and subtract those exponents. Keeping the base, subtract the exponents, we get 10 to the 3rd. And 10 to the 3rd, if we multiply 10 by itself 3 times, 10 times 10 times 10, we're going to get 1,000. So there were about 1,000 times more residents. Step number 4, we could write this out as a sentence. There were about 10 to the 3rd, or 1,000 times more residents in 2016 living in Portland than in 1850. Let's go ahead and try one more. So I've been quite fascinated with the total solar eclipse of 2017, and so kind of why I also decided to start with scientific notation unit. But so I've used a problem inspired by that. We've got the distance from Earth to our moon is about 238,900 miles. The distance from the Earth to the Sun is about 92,960,000 miles. So approximately how many times further is the Earth from the Sun than from our moon? So we're going to follow those same 4 steps. First, we want to go back and write the magnitude for the 2 values we're given, in this case the 2 distances. And since we know we're going to write a ratio form and knows that the order matters, whatever one is listed first in the question, we're going to write as A, and whichever one is listed second in our question, we're going to do that for B. So since it is talking about the Earth to the Sun first, then we want that distance. So that would be about 92,960,000 miles. So go ahead and see if you can determine what the magnitude is. And I've actually wrote it out so we would know that we want to find the magnitude from the Earth to the Sun. And then we're going to write the magnitude from the Earth to our moon. So Sun versus the moon. Go ahead and jot down what you think the magnitude is, and then let's compare. We said that the magnitude from the Earth to the Sun is 10 to the 8th power. So I see 3, 6, 8 digits, so 10 to the 8th power. And then from the Earth to the Moon, I said 10 to the 6th, because I see 6 place values there. So we're ready to set up our ratio. And we basically already have done it in step 1 since we used the proper order. So our ratio would be 10 to the 8th over 10 to the 6th. And so we're ready to simplify that in step 3. Go ahead and see if you can write this out and simplify it using the division rule and our laws of exponents. So if you came up with 10 to the 2nd power, I'd agree. Because when we're dividing and our bases are the same, we can subtract the exponents. In doing so, we get 10 squared, and 10 squared, or 10 times 10, is 100. So we could say, for step number 4, that the distance from the Earth to the Sun is about 10 to the power of 2, or 100 times more miles than the distance of the Earth to the Moon. So there's just a little practice with estimation of comparing quantities. So we utilized our knowledge of magnitude as well as our knowledge of the laws of exponents. So take a moment to make sure your notes are complete, and that'll conclude our video for today.